Hi everyone, this is Team Index Out of Bound. The topic of our project is called Toward Disturbance-Resistant Text Style Transfer. I will introduce the background information of our project. In this project, we are dealing with the text style transfer. The basic motivation of the task is that when talking about the same object, different people might have different opinions, and thus they use different styles to express their opinions. Then we would like to see what would be the differences in these sentences of different styles, talking about the same thing. In this task, we want to use a model to separate content and style of the input sentences and modify the style in some way we specify. And then we want to reconstruct the sentences and we have a new sentences with different styles. This kind of task has many practical applications in terms of text editing, formalization, decipherment, and the presentation style control. Traditional methods for solving this problem is non-paradigmatic methods, which delete the style-related words and fill in the blank with new words. While these methods are relatively stable and not sensitive to noise, they can only deal with simple sentences and generate less diverse results. In comparison, state-of-the-art methods focus on paradigmatic models, where deep learning models are trained to perform the style transfer task automatically. Although these methods can produce very encouraging results, they are vulnerable to noise and outliers, which makes them difficult to use in practice. In general, the source of the vulnerability are twofold. First, the user input are not stable. There can be errors, idioms, that make the neural network unable to recognize the words. Besides, because the model is usually trained with targets that emphasize the correctness of a single word, the output results might be hard for people to read. Motivated by these observations, we develop a new style transfer system that is resistant to these instabilities.
So our main contribution for this project is to improve text style transfer by input and output normalization. Our results show that the transform sentence can be substantially better in both correctness and readability compared to vanilla text style transfer model. Our entire pipeline consists of three parts: input normalization, controllable text style transfer, and output normalization. The backbone of our pipeline is the CTST model, which is essentially a transformer NMT model with a latent space classifier. The model is trained on a yield preview dataset. The CTST model takes as input the English sentence, which is then encoded into latent space representation by the transformer encoder. The latent space classifier then classifies the representation into a sentiment score. To modify the sentiments of the sentence, the representation is optimized to minimize the difference between the original sentiment score and target sentiment score. The updated representation is then decoded by the transformer decoder to generate the target sentence with the expected sentiment. In order to ensure the input language distribution lies under the distribution of the training dataset, we employ a spelling and grammar correction model called Gector to normalize the input sentence. Gector is a BERT-like model trained on multiple grammar correction datasets, including PIE synthetic, Line 8, Nuclei, FCE, and so on. In addition to that, we also apply Gector to normalize the output from the CTST to refine the quality of the generated sentence.
Hi, this is our demonstration. As you can see, this is the main UI, and we are doing the Yelp restaurant review data. And we're providing user two options, explore with the models and dataset overview. We'll start with dataset overview. If you go to dataset overview, you will see a word cloud, which kind of like show a user a better idea of how the word is distributed in the dataset. And the original dataset only contains sentences, and the sentiment column is generated in real time by the TextBob packages. The sentiment is ranged from -10 to 10, where -10 is a really negative review and 10 is a really positive review. We also have a sentiment distribution of the data to give a user a better idea of how the sentiment is distributed. As you can see, the data here is slightly skewed to the positive. Let's go back to the model. In the model here, you can see we have a user input label where user can just type in their customized sentences. This is a really terrible place to die in. Obviously, it's a super negative sentence on the output review. Now let's see if we can make it slightly positive by using our transformation. We're having two models here. The first model is going to be the sentiment transformation model, and the second model is going to be the grammar correction model. The reason is that we found out that sometimes the sentiment transformation model, the output doesn't really make sense. It's not like super user readable. And that's why we introduced the second model. What you're seeing right now, the transformation result is the output of the second model. Let's see, this is a really great place to dine between Starbucks. I guess Starbucks is just like in the groups, there is a word Starbucks. And as I can see, it performs as we expected, and it kind of transformed this sentence into a positive sense. This is going to be our demonstration, and thank you so much.